Ladies and gentlemen, welcome to section 9.1, Graphing Quadratic Functions, part 2. We are going to start with a little review of yesterday's material just to clear up any misunderstandings that we still have about graphing quadratic functions. Please remember that all your steps are in your notes from yesterday, so if you follow along those steps, we'll be absolutely fine. So, our first step, what was our very first step? We had to figure out what A and B are. So A is what's in front of your x squared term. Your A is going to be a -1. Your B is a +6, whatever is attached to your x term. Now we're going to find the axis of symmetry using this guy right there. So it's negative, or it's opposite B, which is opposite 6, over 2 times -1. We simplify that to get -6 over -2, which is +3. So that is our axis of symmetry. So we are going to make a line at +3. Now, to find our vertex, we're going to plug this 3 into this equation to find our vertex. So let's do that. Now I like to put parentheses around what I insert in for my x's. Also, you can do the same thing with calculators and it will give you the right answer every single time. So now I plugged in my 3's, I keep going, I square my 3 first before I take the negative, so it's a -9 plus 18 minus 4, and that gives me 5. So I'm going to put 5 on this axis of symmetry. So I go up 1, 2, 3, 4, 5, put a point. Now there's my vertex, 3, 5. Now I want to pick the other points that I'm going to put on my graph. So since my axis of symmetry is at 3, I'm going to pick 2 points greater than 3, which is 4 and 5. So I'm going to plug in 4 for all my x's. Again, I'm going to put parentheses around it. Plus 6 times 4 minus 4. That gives me 4. So my y coordinate is going to be 4. And then I'm going to plug in 5. So I square my 5 plus 6 times 5 minus 4. And that gives me 1. And so now I put 1 in for my y. Now I'm going to graph from my origin, I'm going to put these points on the graph. So I go over 1, 2, 3, 4, up 1, 2, 3, 4, put a point. Then 5, 1, from my origin, go over 5, up 1, and put a point. Now we want to reflect these points across the axis of symmetry. So it goes 1 to it, 1 away from it, put a point. Here it's 2 away from it, so I go 2 to it, 2 away from it, put a point. Now this graph opens down. Should it open down? Yes, because I have a negative x squared, so it should open down. And then go ahead and do your favorite part of connecting the points. And this should be a U-shaped graph, not a wavy graph, but more of a line that looks like that. And so there is my parabola. Now, if we were asked to state the domain and range, the domain for these kind of problems will be all reals, which is all real numbers. You can put in any numbers you want. The range, since this opens down, we will have a maximum, right? Well, my y has to be less than what number? It has to be less than or equal to my vertex that I found, which was 3, 5, so it has to be less than or equal to 5. Now let's get on to the new stuff. Maximum and minimum values. If the graph opens up, what will I have? I will have a minimum value, and what gives me that minimum value, and we kind of touched on this already, this is going to be a positive A. If that is positive, the graph is going to open up and it will give you a minimum value. But if the graph is negative, or I should say if A is negative, it will open down, giving me a maximum. It will give me a maximum value at what point? The vertex, correct? That is the vertex, the very top or the very bottom of the graph. So let's try it. Now here we're asked to state whether the function has a minimum value or a maximum value, and then find the value. Then we'll be asked to state the domain and range. So first things first, will we have a minimum value or a maximum value with number 2? Well, since this guy opens down, what are we going to have? It opens down, which gives us a maximum value. To find our maximum value, we have to find the axis of symmetry and then plug that in to find our vertex. So let's go ahead and try it. First things first. Our A is going to be -1. Our B is going to be 0 because there is no x term there. So using my negative b or opposite b over 2a to find my axis symmetry, I have 0 over 2 times -1, which is 0 divided by a -2, which is just 0. So now I plug this 0 in for my x to find the value. So it's a -0, that's squared, minus 6, and that will give me a -6. So the maximum value will be -6. My domain is all reals. However, my range is y, and since we have a maximum value, that maximum value is -6, so that means that we cannot go above -6, so all my y's have to be less than or equal to -6. Let's try one more. Here, we have a positive x. So since we have a positive x, we know that it opens up, which tells us that we have a minimum. So now that we know we have a minimum, we have to find our axis of symmetry, plug your axis of symmetry into this guy to find your vertex, and that will be your value. First things first, we have to point out our A. Our A is 1. Our B is going to be a positive 12. Plugging it in here, I have opposite 12 over 2 times 1, which is -12 over 2, which gives me a value of -6. But now we have to plug -6 into this guy to find our value. So let's go ahead and do that. We have -6, that's squared, plus 12 times -6, plus 27. That gives me, just punching it into your calculator, or you can use another line to figure it out, that gives me -9. So my value is -9. Going to my domain, the domain is all reals. Now to figure out our range, since our minimum value was -9, my range, I'm going to use that for my range. So I have y. Since this is a minimum value, I know all my y's have to be greater than or equal to, and that's my smallest value, so it's going to be -9. This was a minimum value. This was a maximum value. And that does it for section 9.1, Graphing Quadratic Functions, part 2. Good day.